What has inspired you to pursue a career in medical machine learning and AI? And has that inspiration and motivation changed or evolved over time?
Um, yeah, thanks for the question. So I think for me, it's been a combination of personal experiences growing up, and then also getting to know more about the field of AI over the last decade by working. And that's kind of shaped my desire to work in medical AI and at the intersection of AI and biology and medicine. So maybe going in a little bit deeper. So I grew up in different parts of India, and one of the recurring themes, no matter where I was in, was access to healthcare for a lot of people was really, really challenging. So it often meant like walking 30, 40 miles in extreme heat, or giving up on a day's wages, or going without food. And so I kind of knew people who had not seen like a doctor in their entire lifetimes, and that often meant like pretty bad things because they couldn't get like expert advice, and so they couldn't deal with their illnesses earlier, and had to like suffer, or sometimes just like losing out on a lot of years of quality life. And so it was also always one of those root node problems that I thought if we could do better at and if we could solve, then society as a whole could, you could raise the tide for everyone. And that was one of my main motivations. And so even like a decade back when I was in my undergrad, a few friends and I we were trying to hack up this app called Ask the Doctor Anytime Anywhere. And so the name is very, very descriptive, and it kind of tells you what we were trying to do. Um, but I think unfortunately, like the machine learning and AI and the technology needed for such a system to exist back then was not really. So even very simple things, right? I think like if you want to build out a smartphone application, but like if like majority of people don't even have phones,
Yeah.
then it makes no sense to build that kind of a feature because it's not going to reach everyone. And then second thing is like I think the machine learning and AI back like a decade back was not maybe ready yet.
Mm.
But I think if you fast forward over the last 10 years, and if you look at the rate of progress in technology and also in machine learning and AI, then I think we are at a much better state. So now, like smartphones are ubiquitous. People are regularly consuming several gigabytes of data in different parts of the world, and that's true even in like rural parts of India or Africa. And smartphones are really enabling a lot of different kinds of applications, and that includes things for health. And then the second thing is just the progress in AI. I think I don't have to speak to that much, but like so much has happened. Like we have AI influencing so many different things in so many different spheres, and especially with all the progress over with large language models and ChatGPT and Gemini and things like that. So I think if you put all of those together, it kind of allows us to dream of this future where
Mm.
world-class medical expertise is like literally in the pockets of everyone everywhere worldwide. So that's been kind of like the dream and the motivation. So it's like, I mean, I've always had this desire, but like when you put together like the elements of that, the key elements of that, I feel like that dream and desire is no longer science fiction. So that's what I'm excited.
What were some of the challenges that you have faced early in your career, and how did you overcome them?
Yeah. So I think for me, it was mostly around things like, um,
Or,
whenever you're getting into an emerging field, there's not a lot of resources about that. And so when I started getting into machine learning and deep learning and AI, and I was doing that as like an undergraduate major in electrical engineering. So it was very simple things for me, like things like actually learning to write code, learning to understand the math behind some of these things. And the resources for me, especially when I was in India, with like very limited access to internet, and even the libraries were probably having books that were like 20 years old, not necessarily like the latest and greatest. So I think the challenge was mostly around the access to the latest resources and the latest research. And that's kind of stayed on. But I think the great thing is again, like if you look at what has happened over the last decade, it's also educational platforms like Coursera and Udacity, Khan Academy, then also YouTube becoming like a major learning platform. And so what's happened is now it feels like anytime there's a research breakthrough, anytime there's a new technology that comes up on the horizon, it's actually much easier for people to pick up because there are so many willing educators out there, people who are willing to like spend hours to teach you about a topic and put that resource on the internet. And so everything literally feels at your fingertips, and it feels like the internet has given people superpowers. But like a decade back, that was not the case. It was a lot of hard work, and you were kind of like always thinking, am I even doing the right thing? Like, where do I find the next thing to learn? And so I think it was those set of challenges primarily, I would say. But they have gotten a lot better over time. I mean, and these days you have people like, for example, Andre Karpathy, who spends like hours trying to uh, like teach the basics of transformer models and LLMs and puts out these amazing resources. People like Sal Khan at the Khan Academy, and so yeah, it's great to see that the challenges that I had to face like a decade back are no longer challenges, maybe. So
When you were starting to learn, I guess, how did you overcome those challenges?
um, yeah, I think it was a combination of actually just being able to hustle and doing the best you can to find the best resources or network and find the best people who can teach you about certain things. And also being willing to go out of your lane and being able to take risks. So I think it was those things. It was a combination of those things.
All
And
right.
so I decided that I did not want to pursue a career in electrical engineering, and I wanted to do research in computer science and AI. And so even for my grad school applications, without any background in CS and AI, I applied for the top schools, and no doubt I got like rejected in all of them. But there was this one professor who took a chance on me, and so it was almost always like that, just being willing to take a bet, see who might like take a chance on you, and then anytime you get that chance and opportunity, just spend like do whatever you can, whatever is within the limits of possibilities to like learn and give back to the faith that they have put on you, right? And so like anytime there was an opportunity to learn about something new, uh, like spending a lot of hours, like spending the entire night debugging and coding and learning. And so it was like a lot of those things, especially in the formative years when the field was taking off. Um, and so it was that, and then I think I got a lucky opportunity to be one of the early engineers at Meta AI Research back in 2014 when the lab was just getting formed. And so it was that time when I learned, okay, like not only how to do research, but also how to take some of these models and systems and deploy them to users at scale. And when I mean scale, it means hundreds of millions of people. And so being in that environment and being with those people was again, I think, the most incredible learning experience. And then you got to learn about all the details and the nitty-gritties, and you became aware of like, okay, what are the challenges, but also maybe what are the common themes across different areas where AI was being applied. And then you had like a front row seat to the, the rocket ship that was taking off. So I guess yeah, it's just a combination of those things: being in the right place at the right time and being able to hustle and take risks, especially early in your career, and being like very open to learning new things.
What's a fun fact or like interesting piece of information about your field?
Um, I don't know if there's any fun fact about my field per se, because it's like probably one of the most widely discussed things on the internet,
Yeah.
and it's part of the zeitgeist today. It seems like people know everything about AI, and there's like so much happening. Um, so yeah, I think it's kind of hard for me to state that, but yeah, maybe like I think it would be surprising, but there was a point of time when I guess actually there weren't a lot of people who were believers in like deep learning and convolutional neural nets, and that was the case until 2012 when there was that image net breakthrough. So I think that the thing is again like things go around in cycles, and the key thing is if you believe really in an idea, it's important to be able to uh, maybe ignore, say, some of like the people who are like criticizing you and still being able to like focus and push through. I think ultimately it's important to be driven by the truth, and science is all about like uncovering truth. And so that means you have your biases and intuitions, but like ultimately letting the data speak for itself, and then figuring out okay, what are the challenges that you need to solve to get to that truth, right? The next level of truth. And so there were a few researchers who did that, and famously now they've all been awarded the Turing Prize, and I think no praise is enough for them. But yeah, I guess that's maybe the fact is the fact that like AI goes around in cycles that like springs and summers, but also like long winters. And that's also true for most other technologies as well. And so I think the most important people who rise up to the top during any like hype wave or something like that are actually the people who have spent like years and years in like oblivion trying to prove out the technology. And so I think being able to do that is, I think, like the superpower. Like anytime we, for example, see like people at the Olympics with the medals, what we don't see is like the years and years of hard work and repetition and consistency that goes in.
Yeah, I think that's a really insightful answer. So obviously one of the recent, I guess, kind of and big innovations was MedPalm. For a like general high school audience, maybe, do you mind just describing what MedPalm is?
Yeah. So again, thank you for saying that. I'm not sure, not so sure that it's like that big of an innovation, but I think it's an interesting idea, and the results were definitely somewhat of a breakthrough. Um, so MedPalm is like a large language model that has been tailored for medical tasks and applications. And the motivation for doing that is actually very, very simple. So I mean, you have like models like ChatGPT and Gemini and Claude and others. Uh, these models are like a very smart friend of yours. So you can, talk to them about physics and poetry and philosophy and whatever that you want to talk to them about. Um, but like, say if you have like a medical concern or if you need like medical advice, uh, I would hope that you actually don't go to the smart friend of yours, but rather you go to a doctor, right? Someone who's licensed to practice medicine, someone who has undergone rigorous training. And so, if you have to use like AI systems in medicine, it should be no different. So we should be using models and systems that have been specialized, that have seen the right kind of data that is relevant to the domain, have like undergone rigorous verification and validation, similar to how like doctors go through. And those systems should also understand like the values of the practice of medicine that have evolved over like decades and centuries. Chief among them being like doing no harm, and patient comes first, right? And so you need systems that are really, really specialized to medicine. And so MedCom was kind of like our attempt to do the same thing, or it was our first attempt to do the same thing with medical large language models. And I think in the process of doing that research, the key result was actually our systems achieving initially like passing level scores on US medical license examinations, and then expert level scores. And just to put that in context, this grand challenge has been there in the field dating back several decades. Like even in the 1970s, 1960s, we had like famous professors who are literal legends trying to build out like clinical decision support systems with AI that could be used in care. And so it's been a long-standing endeavor in the field. And people have tried different techniques, logic-based systems, early NLP-based systems. But even until like, I would say December of like 2022, the best performing systems on these medical question answering benchmarks were actually really, really poor. But then with the advent of large language models and having models that could encode like vast majority of the internet and the process of doing that, encoding a lot of knowledge about medicine, we started having systems that were much more reliable at medical question answering. And so once you do a little bit of like tuning and alignment on top of them, you got these breakthrough systems that are immediately starting to do like really good on these kind of questions. And so yeah, that was the headline result, like a breakthrough in terms of having like an AI system actually cracking the USMLE. So that set up the that set up the research. But again, the key thing to note is that cracking the USMLE doesn't make you a good doctor. So there's a lot more to be done.
And so you kind of talked about the creative process or idea behind it, but I imagine the process of making MedPalm wasn't exactly smooth sailing. Were there any like challenges that you guys experienced when making it, and how did you overcome those?
Um, I mean, again, like maybe it's a bit of a contrarian answer, but I think the key thing was actually just to identify the opportunity over here. And so, like, I'm very, very fortunate to work at Google with like incredible smart folks. And like, we were able to see this wave coming earlier than most. So we had systems like Palm and Lambda, which were also language models, and we were seeing the capabilities of these systems. And so, I guess the key, I wouldn't say the challenge, but like, the key insight was seeing that yeah, this technology is coming online, and like, so how do you adapt and make sure that these systems can be safely used for beneficial use cases, and prominent among them being in medicine, right? And so for us, it was always that thinking, okay, this technology is maturing, and in a year's time, we can see like the trends. Um, that was, I think, the key thing, the insight that um, it wasn't like early to do that. It was the right time to do that, and like convincing people around you to be able to like come with you on this research and in this research journey. But once you're able to get over there, then I think at a place like Google, you have like all the magic, all the people, all the infrastructure to be able to like pull up this kind of research really, really fast. And so a lot of the work or the challenge actually lies in just making sure, or just in some way, actually convincing the people the timing to do something is right. And once you get over that wave, and like once you are able to clearly articulate and formulate a problem, then you get like a lot of resources and a lot of energy and a lot of motivation to so invariably, like I think solving problems, especially at like big organizations, is almost always about convincing that something it is the right time to do something.
What do you think are some of the most exciting recent developments or trends that you see that might happen in the future with regards to like this medical field and AI?
Yeah. So again, I'm a little bit biased, but for me, like the work that we've been doing actually with our, I wouldn't say it's a successor to MedPalm, but it kind of builds on that kind of research. And so we have a system called ARMY, which is our effort to build out like medical superintelligence systems and democratize them. And so the early results that we have with our ARMY system is actually very, very encouraging. And so we did these randomized studies with patient actors, but I mean that's the first way in which we first method with which we evaluate these systems. And so we did these studies, and we see that these systems, at least over like a text chat interface, are able to provide medical advice and diagnosis like better than actually human PCPs, human primary care providers. And perhaps a more profound thing is the patient actors were rating these systems to be more empathic in nature, more friendly in terms of like a conversational perspective, better at building rapport and things like that. So I think those results are very, very encouraging. But again, the key thing to note is that human doctors are not trained to chat over like messages or text chat. Rather, it's almost always a face-to-face interaction, or if you back up to a video call. And so I guess the next step for us is figuring out like how do you bring forth some multimodal capabilities into these systems so that it can not only chat with you, but also has like eyes and ears and a voice. And then you can have like more naturalistic interactions. And then seeing if you're able to compare well with GPs in those settings, with human doctors in those settings. And if you're able to start to do that and show that, then I think that sets the stage for democratizing that kind of superintelligence systems and making it really available everywhere. And like putting like medical superintelligence focus everyone. So I think that's like the exciting like research from the trend that we're seeing. And then the second one is more around our understanding of biology, and even there, like my extended team in Google DeepMind, we've pioneered systems like AlphaFold that have like led to new breakthroughs in a lot of different fields of biomedicine. And I do think that like AI is going to help us improve our understanding of biology, understand disease trajectories over time, unfold, and help us make better predictions about like what kind of therapies to build, and really help us like scale personalized medicine to everyone, right? And so that's kind of the dream and the goal. Like, so
Mm.
can you build out like an AI physician scientist that not only democratizes access to healthcare to everyone, but also improves the understanding of human biology and
Mm.
helps us cure all diseases. And if you're able to do that, then I think you're going to help a lot of people live their best lives, their most optimized version of themselves, and really go after whatever they want to do in their lives. So that's kind of the dream and the goal, and I think that's possible.
What are some within like for AI and like this medical field again, some common misconceptions that you may encounter?
Um, I think maybe one thing is a lot of like people who come in early into the field of AI or machine learning, they tend to get attracted maybe a little bit by, say, working on the latest and greatest architectures or the models themselves. Uh, but like invariably, that's not where the breakthroughs come from. And it's always cool research to do, but you would find that if you actually spend the same amount of time and cycles on the data that goes into these systems and how you set up your problems and how you evaluate these systems, then you'll actually get a lot better results, like a lot more bang for the buck. And so that's a process that I think everyone learns when they're trying to solve a problem. They spend like maybe the first 80% of their time on the models, trying out like fancy new things, fancy new ways to like arrange these blocks, because these are ultimately like Legos at the end of the day, and it's like really fun to like play around with them. But you realize that actually it's the input and the output that matters, like the data that goes into the systems. And maybe that's not so interesting to work on. That's not so fun, but that's where you get like uh, the most benefits.
Mm.
And so that's just some practical advice that I have personally learned over the years. And so, like, I would advise anyone who's like really cares about like practical applications of AI in different fields to spend a lot of time on like the data instead of like the models, and that's where you learn a lot. Um, yeah, I would say that that's kind of the main. It's not a misconception, but it's like
Yeah.
rather just a learning that people encounter when you're working in the field.
Yeah, that's interesting. Do you mind maybe providing an example of like what you mean by like input and output and the data that you want to focus on?
Yeah. So I think again, like a very simple example would be like these models are kind of like powerful. So whatever data that you give these systems, these models would fit them. But I think the more clean data that you give, the more
Mm.
uh, well curated data that you give, the better they are. So it's not too again different from how humans learn, right? And so if you're learning from a good textbook that has very clearly articulated how like a given concept is like evolves and like has a very thoughtful presentation, then it's much more easier for you to understand.
Mm-hmm.
Or same like if in a classroom, if you have like a good teacher who's able to very clearly articulate and teach you, that's much more easier than having like a bad teacher or a bad book, right? And so you probably see these examples very often. And so it's the same over here. So the data is like the teacher to the model.
Mm.
It's what you learn from. And so the better teachers that you have, the better textbooks that you have for these systems, the better they can learn and the more efficient the learning process will be. And so that is where I think it's, and so like changing the model is almost like changing the student, but that's not the goal. The goal is to actually keep the student fixed and like have them learn the best possible representations, and like really be like a great student. And so that means like actually as like teachers or like the kind of inputs that goes into these systems, you want to make them as good as possible.
Right.
So hopefully that example makes sense over here.
Yeah, that's definitely helpful. And so what advice would you give to maybe young people or high school students who would be interested in entering this field? And do you have any specific resources that you may suggest?
Um, yeah, I think it's a bit of an interesting time over here, and because there's no doubt that there's a lot of hype in the field, and there's like a lot of things happening, and so I think the challenge is actually to not get overwhelmed by everything that's happening, and focus maybe on actually learning the basics and the fundamentals. And so I still tell people that Like the best way to learn about any field is actually to go and pick up the best possible textbooks in those fields and spending a lot of time understanding the examples. But it's not just enough to like just read. I think it's also important to be able to implement on your own, because the more you're able to implement things, and the more, I think, the better your understanding becomes. And so learning to code and like prototype these systems and playing around with the data and the models, I think that becomes very, very, very important. And so once you're able to do that, um, and if you're able to combine that with, say, like some applications that you prototype and like put it on the internet and like get feedback from people, then you build up like the knowledge, but also the confidence needed. And then you can do, and then I think the world is at your feet. Like you have the basics, you have like the fundamentals. And then if you want to become like an applications oriented developer, you can do that. You can build up like lots of crazy applications. But also if you want to just become like a researcher in the field who advances the fundamentals of AI, that is also possible. So I think the advice is probably to just stay focused on like the fundamentals, like pick up like a good textbook. There are like plenty of resources on the web, like there are amazing teachers. There's a lot of amazing videos, and so it's kind of become easier to learn about them. But the flip side is also that there's a lot of noise and hype, and so being able to like ignore all of those things and just focus on the basics and the fundamentals is like the key. And then maybe, yeah, the other thing is not get overwhelmed, because now there are like millions of people who are going to be interested in AI and talking about AI. And so then the question becomes, okay, like, what is your niche? Like, what is your area that you really care about? And I think that comes down to like who you are as a person and what are your personal experiences. And the more you are able to find out, okay, this is the thing that I truly care about, and this is the thing that allows me to get out of bed every day and like really put my best effort in. If you're able to identify that kind of problem, and then I think like you can use the skills and the resources that you have, the skills and the fundamentals that you have learned, and then take it to the problem that you really care. Yeah, and then just have a lot of fun along with it. So.
Okay, yeah, thank you. That's very helpful. I think people will find that advice useful. And maybe do you have any resources, like specific resources that you might recommend or suggest?
Yeah. So again, I think there's a lot of like entry-level textbooks into deep learning and AI. So I would definitely recommend those, and especially ones that have like code samples provided. So the more you're able to see, okay, what is the basic building block, but also what is the code to implement them, then it becomes kind of easier. And then like there's a lot of like courses on places like Coursera and Udacity. I would definitely recommend that. And then once you get like maybe a little bit more of a basic block, like basic understanding of these technologies, then going into YouTube and learning from people like Andre Karpathy and their courses at Stanford or whatever that they have. I think those sort of resources are generally just enough. I know like maybe a lot of the people that you're going to be sending this video to are probably in high school, but I think it's not too early ever. I think age doesn't matter. It's almost always the willingness to learn, and then being able to, and never be afraid to reach out to people, because you never know who might be interested in helping like you learn and teach.
All right, thank you. How do you stay updated with latest technologies and advancements in your field?
Yeah, I think it's again another interesting question. I think it varies from person to person. And for me, now I've come to this steady state where a lot of the information that I really maybe require or need comes from the people around me. And so having like maybe like really smart people in your network who are up to date on a bunch of different topics, I think that kind of helps you. But it's also important to have people who have like a diversity of opinions. So like they're not like helping build up the echo chamber or the filter bubble for you. So just having a lot of smart friends who are well versed in various different topics, then you can learn from them. And then I'm also kind of like a believer in the fact that if something is like a true breakthrough, and then it will be relevant even like 6 months down the line or a year down the line. And definitely like a true breakthroughs are relevant like 10 years down the line, right? So you don't necessarily have to rush to be up to date of things, right? So you can take your own time. And so it's almost like surfing. Like if you go surfing and if you catch like maybe like a smaller wave, then you don't like get the right kind of, yeah, it's important to catch the right wave so that you can surf. And so it's all about timing. And so you don't have to rush things. And so being patient and like having a good network around you um, is I think enough. Yeah, I don't think you have to be up to date about every single thing and like fret over okay, oh, this thing happened this week, or I need to like learn about this thing. No, I think that's not the case. I think like any true breakthrough will be relevant a week down the line, 6 months down the line, a decade down the line.
Okay, thank you. And so I guess kind of wrapping up, you mentioned your peers are important, and like you mentioned some people on online, but I guess to wrap up, who are some of your role models or mentors, or kind of in your field, and like how have they influenced you?
I think I don't necessarily want to say I have like one role model or mentor or something like that. I think my opinion on people is that like people have lots of good things about them and also a lot of like maybe not so good things about them, and everyone's like imperfect. And so the key thing is to study a person carefully and then pick out the things that are maybe good about them but also like relevant to you and try to incorporate those things. And so for me it's not like one person per se, but it's like actually hundreds of people that I've like seen or come across in my life and seeing okay what are the good things about them and what helped them become successful and trying to like cherry pick and incorporate those aspects. And so like for example like Jeff Dean at Google, who is like this stellar engineer, like legendary computer scientist. So for me, it's like not just the technical prowess of Jeff Dean and his ability to like build up systems that have massive impact on people, but also just how nice of a human he is, like how open he is, how available he is. And in fact, Jeff seems to have like more time for people as he becomes more and more famous and goes through lines. And so like that matters a lot to me. It's not just about like who, like what kind of it doesn't matter to me if you're like a prolific researcher, but I think ultimately it's important to be like a very good human. And so like people like Jeff Keen are like stellar examples of that. And then I think there are like plenty of other examples. Like I think, for example, scientists like Jan LeCun or Bob Langer in biomedicine, and these are researchers who have had great ideas, but like the field did not consider them for a long period of time, and they persisted through it. So persistence is another thing that you learn. And so any kind of scientific breakthroughs, I think it almost always is a story of like someone being foolish enough to persist through them for like decades. And so learning that skill is also, I think, important. And then I think like as you grow and progress in your career, the art of like articulating and communicating things. So learning from people like Andre Karpathy how to like communicate concepts and like teach and educate people. So yeah, like I could go on. There's probably like 100 people that I can know over here, but like I think those are the kind of key things that matter, like technical prowess and like persistence, but also just being an overall good human.
Yeah.
And setting and being like a role model for that.
Yeah, that was really helpful and insightful. That was pretty much it. Thank you so much for meeting with me.
If you need anything else, just let me know.
All right, thank you so much.
Cool. Yeah, great meeting you, Max. And I'll send over the resources to some of the textbooks and video lectures that I mentioned.
All right, that's great, and I can include a link to them too. So.
Perfect.
All right,
Cool.
thank you. Have a nice day.
Thanks so much again. Enjoy it.